In science, units are king. When you make a measurement, it's meaningless unless you know what unit it was measured in. This is one of the key differences between maths and science. For much of the time in maths, you're interested in numbers just for their own sake. If you mention the number 10, then that means exactly 10, no more, no less. But in science, if you say you've measured something to be 10, you'll immediately be met with the response, 10 what? Well, you might say, I'm holding a stopwatch and I was timing this cyclist, so obviously it's seconds. Really? Obviously? What if it were minutes? Or the cyclist was doing an endurance event and it were hours? Or maybe you're timing the cyclist's heartbeat, or how long it takes the bike wheel to complete 1/360th of a revolution. And how do I know you're not measuring in shakes or jiffies or micro fortnights? Well, okay, by looking at the stopwatch. But you see my point. If you don't have the unit, then the number itself gives you no useful information. So our watchword in science is no naked numbers. Make your numbers decent by giving them units. In chemistry, we use metric units. The modern form of the metric system is known as the International System of Units, which has 7 base units. And from these, the units of all other quantities can be derived. 2 of these units are not so common in chemistry. There's amperes, the unit of electrical current, although you may encounter this in electrochemistry, and candelas, the measurement of the intensity of light. The other 5, though, will turn up frequently. We have kilograms for mass, meters for length, seconds for time, Kelvin, degrees Kelvin for temperature, and moles for quantities of atoms and molecules. Kilograms, meters and seconds you'll already be familiar with. Degrees Kelvin work much like degrees Celsius. Moles are the unit which is central for chemists. We'll be using this unit constantly as we learn how to calculate chemical quantities. Of course, it's not enough simply to have kilograms, meters and seconds. Sometimes we want to measure things that are very light or very long or very fast. So then we change the size of the unit by adding a prefix. Some of these prefixes you know already. For instance, kilogram has one built in. Kilo means 1,000, so 1 kilogram is equivalent to 1,000 grams. The prefixes you most need to be familiar with are these: kilo, deci, centi, milli, micro, and nano. You can always look the conversions up, but if you know them off by heart, it speeds things up when you're ploughing through a long calculation. So let's use meters as an example. 1 kilometre is equivalent to 1,000 meters because kilo means 1,000. Deci means a tenth. A decimeter is equivalent to a tenth of a meter, or 0.1 meters. And this means the same as saying that 10 decimeters is equivalent to 1 meter. Centi means 1/100th. 1 centimeter is equivalent to 0.01 meters, or we can say that 100 centimeters are in a meter. Milli means 1/1000th. 1 millimeter is equivalent to 0.001 meters, 1 times 10 to the minus 3 meters. Or we can say that there are 1,000 millimeters in a meter. Micro means a millionth. 1 micrometer equals 1 times 10 to the minus 6 meters. Or we can say that there are 1 million micrometers in a meter. Micrometers are also sometimes called microns. And finally, nano means 1 billionth. So a nanometer is 1 times 10 to the minus 9 meters. Or we can say that there are 1 times 10 to the 9 nanometers in a meter. Make sure you're familiar with these prefixes. You'll encounter them frequently.